Hello everyone, welcome to UpSmart IAS classes, and I am your Reddy Prakash. In the previous classes of chemistry, we have studied carbon and its components, and in this upcoming chapter, we will be studying everything about the chemical equations and its balancing nature. How we will balance the chemical equations? If we balance, so how is it named as? This will be the scope of the upcoming chapter, okay? And this is a very easy chapter. Usually it seems very difficult because we have a preoccupied mind. We have seen so many types of equations. We would have seen types of equation, confusing equations, but we have set a base, what an atom is, what an element is, what is oxidation, reduction, many things we have seen, and all these things will come as a useful hand in this chapter. And believe me, this is a very easy chapter. One question will come from equations for sure, and I am pretty sure, 100% sure, everyone who have watched my videos will solve it for sure, and will be getting those 2 marks which are going due to cross that line of qualifying or disqualifying. Okay, so without much wasting time, we can get on to the chapter. So before doing this, I'll give a slight example for you. What is that? One second. So what do you mean by equation? What do you mean by a chemical equation? You have seen chemical equations, right? 2 or more things combine and produce 2 or more things. That is called as chemical equation. That is called as chemical equation. How? How, sir? See. AB plus CD. AB plus CD. This can either give rise to ABCD or A plus B plus C plus D. Okay, or it can also give rise to AC plus BD. We can have possibilities like this. When 2 or more things react, it can either make up. What is happening here? It is making a new bonds. It is making up a new bonds. New bonds are made here. Making bonds. A bond is been created between AB and CD. So it is ABCD now. Making up of new bonds. Here breaking bonds between AB and breaking bonds between CD. So the second kind can be breaking bonds, and this is the other kind. What is happening here? B from here is going to here. C from here has come to here. So there is displacement. Displacement not in just one compound but both the compounds. Displacement has occurred in both the compounds. C is also displaced. So displacement reaction. This is a displacement reaction. And is it only one compound reacting? No, it is 2 compounds displacing their elements both the sides. So it is called as double displacement. I explain all this with examples, but I am just giving you a brief introduction. So if 2 or more compounds react, they can either make the bonds, they can break the bonds, they can displace themselves. If one displaces, that is displacement reaction. If both the compounds displaces and exchanges its elements, it is called as double displacement. Okay. Now what is another thing is, these are called as the reactants. The reactants, because these are reacting. These are called as the reactants because these are the ones reacting now. These are called as reactants. And all the above, which are got as a result of reaction, which are produced as a result of reaction, are called as products. These are reactants. These are products. So a chemical equation is the equation which can either make the bond, break the bond. These are two. And while making and breaking, there can be types like displacement, double displacement, or the breakage of bonds. There can be many kinds. But these are the major things, and these are called as reactants. What reacts are called as reactants. What we obtain, what is produced, are called as products. This is fine, right? This is a chemical reaction now. So we'll go back. It is easy, right? It is easy. Understood the basics? Basics are fine, right? See now, when the basics are fine, your preparation is fine. 99% of the students fail with the basics. They don't understand the basics. Once you get a hold of it, every concept is a cakewalk for you. You have to believe in this. Okay? Fine. See, what is a chemical reaction? Process that either makes or breaks a bonds to form new substances. What are new substances called as? Products. Fine. So reactants are starting substances. Products are new substances. We got a hold of this? Easy? No. If you see few of the very important daily life chemical reactions, these are the most important ones. Okay? For example, curd. The basic element involved in this is lactic acid. Digestion. In digestion, it is glucose, amino acid, and other acids like hydrochloric acids. Okay? Respiration. In respiration, we utilize carbon dioxide, water. Okay? Rusting of iron, hydrated iron oxides. The formula is also important. I'll keep this as a separate example. I will discuss this. Okay? But it is hydrated iron oxides. These make up the, when the iron reacts with water. See, at one side we have iron. The other side we get a rainfall. Rainfall is nothing but water, right? We have this knowledge of when the water falls on iron, it gets rusted. We know this. Water is H2O, iron is Fe. When water reacts with iron, what happens is hydrated iron oxide. Water has hydrogen and oxygen. See, hydrogen, oxygen, iron. Hydrated iron oxides are rusted irons. This is the rust name of the rust, chemical name. We'll discuss the chemical formula, how it is formed, everything going ahead. Okay. Next is burning of fuels. Fuels are carbon dioxide, water. These are released when you burn the fuels. Ripening of fruits. These are important. Glucose and especially ethylene derivatives. We spray the chemical compounds to ripen the fruits. For example, we get the early ripened mangoes. How do we get it? Mango was green color and it is not completely matured, but we will get the mangoes in January, February, March itself. While the ripened mangoes, the actual matured mangoes, we should get in June or May end. Why we'll get in February or March itself? We'll bring the immature mangoes. We'll spray the ethylene chemical on it. That will increase the ripening rate. We'll get a completely yellow color mango but with less taste. Why less taste? Because it is not matured completely. Those are immature mangoes. Ethylene is sprayed on it. Okay, understood why the mangoes taste less these days? Because chemical compounds are sprayed on it. Similarly, bananas. Have you ever observed? Banana will be completely yellow these days. In the supermarkets. But when you eat it, you don't feel like it is ripened. You don't feel the taste because ethylene is sprayed on it forcefully. So it gets ripened. It gets its color. But the taste, no sir. This is a process. Easy, right? Simple. You have seen these things on a daily life, but these are the main elements or compounds involved in it. Easy? Okay. So the core concepts. No. 1 second. Yes. And how do you feel a chemical is? How do you sense a chemical reaction is taking place? How do you sense it? When you have to sense a chemical reaction is taking place, you either observe a new gas is being released. See, you can see a smoke coming out of silencers of the motor vehicles. That means a gas is coming out of silencers of the motor vehicles. That means a chemical reaction is taking place in the engine of motor vehicles. Chemical reaction is taking place, that is fuels are burning over there. Due to that, a new gas is formed and released through silencers. Okay, so you should observe a new gas coming out, or you can observe a formation of precipitate or the salts. I told you, mixed hydrochloric acid with NaOH. What you will get is NaCl. You will get the common salt, and various other things will give you the precipitate like this. See, it was liquid. When you pour, you will get a precipitate like thing. It can happen with this potassium iodide when mixed with lead nitrate. You will get a yellow precipitate. Okay. Similarly, barium chloride, sulfuric acid. It's hard to remember these formulas. I know, better you skip these formulas. These are only for the examples purpose. It forms a precipitate. Fine. Next, it should either release a gas, form a precipitate. Then you can surely say, okay, a chemical reaction is taking place. How do you sense a chemical reaction is taking place? New gas, precipitate, or there are other ways too. You can sense it when the color changes, when the color of reactants changes. We observed it. Take a pinch of organic compounds. How you test whether a carbon is there in the compound? Take a pinch of compound, heat it, mix it with lime water. If the color changes, then carbon is there. That means when a reaction takes place, color changes. Similarly, if a color changes for sure, then a chemical reaction is taking place. If color doesn't change, doesn't mean chemical reaction is not taking place, but the other tests like this can be utilized. If color doesn't change, we can check if a new gas is forming, if a temperature is changing, if there is a precipitate formation. So these will be indicators of chemical change, chemical reaction. The other thing being change in color. See, orange color can become green color. Chemical reaction. You can also observe your silver which is stored at home, the silver which you wear it on as a ring or as a ornaments, okay, will change gradually into green color, because when the silver reacts with the oxygen around us, a green color rusting is formed. That is a chemical reaction. So chemical reaction is happening, color is changing. Yes. And change in temperature. If you can burn the fossil fuel or the methane, CH4, what you will get? You will get carbon dioxide, water vapors as well as heat. That means change in temperature is an indicator for chemical reaction taking place. Fine. Or there can be a change in state of the reactants. You burn a candle, firstly it will become liquid and then it will become gaseous product. A change in state of a reactants is taking place. That means a chemical reaction is taking place. These are the indicators of chemical reaction. Easy? Very easy, sir. It should be easy. Next, balancing a equation. How do you balance the equation? Before I tell you the steps, I'll tell you the balancing the equation. So before getting into that, let me take the whiteboard which I used earlier. See, there was ABCD. What you got as a result? ABCD, ABCD, ABCD. Why only this? Why not others? Because we have a law called as law of conservation of mass. mass remains as it is. You don't get new elements or anything. The same elements remain, the same mass remains. This was given by Anthony Lavoisier. In the first class I discussed. Anthony Lavoisier gave this law of conservation of mass. The same amount of mass will remain even after the reaction takes place. Okay. Law of conservation of mass. Equal elements must be equal on both sides. Equal on both sides. Now see, how do you balance it? Say this reaction is given. They might ask you to give a balanced reaction. They might ask you to select a balanced reaction among the 4 options. Now see, how many Fe do we have on this side? We have 3 irons. Fe, for your information, is iron for those who don't know. Okay. Fe means iron. How many irons do we have on this side? 3 irons, sir. But on this side there is only 1 iron. So what should we do? Multiply this by 3. Now the irons are balanced. Fine. Easy. Now, how many oxygen do we have it here? 4 oxygen, sir. How many oxygen do we have here? Only 1 oxygen, sir. Only 1 oxygen. So what should we do? Multiply this by 4. Multiply this by 4. Multiply this by 4. 4H2O. So oxygen is balanced now. So the next one, how many hydrogens are there here? 2 hydrogens, sir. 2 hydrogens. How many are here? 2 into 4. How many are here? 8 hydrogens, sir. 8 hydrogens. To balance this, what do? We multiply this hydrogen with 4. Now everything is balanced. 3 iron, 3 iron. 8 hydrogen, 8 hydrogen. 4 oxygen, 4 oxygen. You can balance like this. What I am doing? I am analyzing what are the elements are there on the both the side. I am balancing each one of them on either side. Then I am finally calculating them if the elements are equal on LHS as well as RHS. That is the left hand side, right hand side. Easy. See now, the correct equation is 3Fe, 4H2O, Fe3O4, 4H2. This is the correct equation. This is how we balance the equations. Now, the steps are, we should write the skeletal equation. This is the skeletal equation. Next is count the atoms. As I did, how many iron, counting the atoms. Next, balance one element at a time. Balancing one element at a time. If there is 1 iron, we should have 1 iron. We have 1 iron, 3 iron. I am balancing it by multiplying this by 3. Balance one element at a time, not everything at a time. Don't be over smart. Just be smart with the UpSmart. Okay. Next is verify that atoms are equal at the final. Easy. Balancing is very easy. Next. Next is type of chemical reaction. This also is very important. Type of chemical reactions are also very important. I'll tell you. It's very easy. How you should do is, say, this is combination reaction. What is combination reaction? What is combination? Combination means when AB combine to form AB. I told you, right? New bonds are made. AB plus CD give rise to ABCD. A bond is made. That means AB and CD are combining. That is a combination reaction. A plus B give rise to AB. This is a combination reaction. Both are combining. Next example, CaO plus H2O. Both are combining to give CaOH2. CaOH2 the whole. This is combination reaction. That is quicklime. Quicklime is CaO. Water gives rise to slaked lime. Combination reaction. Just understand what usually examiners do is they'll give this reaction. They'll tell you to find the type of reaction. The options will be combination reaction, redox reaction, displacement reaction, double displacement reaction. So 4 option, you have to pick the right option. Now what is happening? Both are combining to form a single compound. So it is a combination reaction. Questions will be easy, don't worry. Just that we should understand the crux of it, the meaning of it. Next is exothermic reaction. Thermic means heat. Exo means outside. Means heat is coming outside. Means a heat is being released. That is the meaning of exothermic reaction. Those are the kinds of reaction that release the heat. I told you, we burn the methane, we burn the hydrocarbons. What we'll get? We'll get the carbon dioxide, we'll get the water vapor, and we'll get the heat, no? So that is a exothermic reaction. Burning, exothermic reaction. And the respiration. Have you ever observed? We respire, and we release this thing, no? We release the air. When we take, we don't feel like we are taking hot air. When we leave out, we feel like the air is coming hotter. Why? The glucose is being broken down into carbon dioxide, water, and the energy, that is exothermic. Heat is being released. That is respiration. And other examples being formation of compost, decomposition of vegetable matter. This will also release the energy, release the heat. That is also an example of exothermic reaction. Easy. Just the names. Understand why the names are kept. You will understand what kind of reaction it is. You just have to pick what kind of reaction it is by analyzing the equation given in the examination. Just 99% of the time, this will be the type of question. The other 1% we don't know. That is why we are discussing each one of them in detail with examples. Okay, fine, connected, understood. Next reactions are photolytic reaction, displacement reaction. And in the displacement reaction, what is the role of reactivity series? Reactivity series means a series of elements will be arranged. In the increasing or decreasing of order of reactivity. Say we have iron on one hand, copper on other hand, gold on the other hand. Okay, iron, copper, gold. Which is more reactive? Which will get easily rusted? Iron, second is copper, third is gold. So the reactivity series will be gold, copper, iron. That is the reactivity series. Means the more reactor one will get displaced easily. It will displace the other ones easily. The more reactor one will displace the less reactor one easily. If copper is reacting, that is a reactant, and if you want copper is reacting with iron will displace the copper's partner. Iron will displace the copper's partner, and it will take that partner. Copper will be alone now. That is the role of reactivity series. We'll understand this again. Again, I'm telling this, I'm giving us a brief introduction so that you will not be confused when I discuss them. Fine. Now, photolytic decomposition. What is photo? Photo means energy, usually the sun, the heat. Decomposition means breaking. Combination means coming together, combining. Decomposition means breaking. Now see, we have silver chloride. AgCl. 2AgCl is a formula of silver chloride, right? When silver chloride is exposed to sunlight, what happens is silver and chlorine gets separated. This is as an example of decomposition, especially photolytic decomposition. And silver chloride will be usually white in color. When the reaction takes place, silver will separate, that will become grey in color. Silver chloride turns grey in sunlight. Okay, understood? This is silver chloride. Next, decomposition, photolytic decomposition, easy with this. Next is displacement reaction. I told you what is displacement reaction. A reactant displaces the other reactant's partner, that is displacement reaction. If both the partners are replaced, then it is called as double displacement reaction. We'll understand what is this displacement reaction. A more reactive element displaces less reactive element to form its compound. Say no, I told you. Copper is relatively less reactive. Zinc, iron and all these are more reactive. The cheaper metals are more reactive usually. Zinc are more reactive. Copper is less reactive. So what happens when you mix zinc with copper sulfate? Zinc with copper sulfate. Copper is less reactive, right? Zinc is more reactive, right? It will tell copper, shut up and go. I am more powerful. I am more reactive. Leave your partner. I'll take your partner. This is like this. So zinc will combine with SO4, ZnSO4, and copper will be left alone. Zinc, copper sulfate. Zinc sulfate, copper is left alone. This is displacement. If Z also has a partner, say X, copper has a partner, say Y. If the partners are exchanged, then it is called as double displacement. Displacement of both the compounds. Double displacement. I'll tell you. See now, copper sulfate, zinc. What happens is zinc will come here, it will take the sulfate, copper will be left out. Zinc sulfate, copper. Zinc displaces copper. What is the role of reactivity series here? That means the more reactive metals displaces the less reactive metals. Same like iron and copper. Iron will take the sulfate, leave out the copper. Copper cannot displace iron from FeSO4 because copper is less reactive than iron. I made sure you are understanding, right? And next, double displacement theory. This we discussed. General formula. One second. This we discussed the general formula, example, role of reactivity series. Now the double displacement. What is double displacement reaction? When two compounds exchange ions to form new compounds. See, AB and CD is becoming AD plus CB. It is exchanging. A is leaving out B to C. C is leaving out D to A. Displacement of the ions. It is forming new compounds like BaCl2, NaSO4, NaSO4, Cl2 and sulfate, chlorine and sulfate. These are exchanging. Ba is taking SO4 from here, sodium is taking chlorine from here. Double displacement. Now what the examiner does is they'll give a similar equation like this. This equation or a similar equation like this. They'll try to identify the kind of chemical reaction which has taken place. Now it is easy, right? You will find it as double displacement. Very easy, sir. I'll find it, sir. Next is decomposition reaction. I told you what is decomposition. Breaking of the compounds into two or more compounds is called as decomposition. There are kinds of decomposition reaction. We have studied photolytic decomposition. This is done. Silver, that is done. Next is thermal decomposition. Photolytic means sunlight should be there. Thermal means any kind of heating. Thermal means heat. Any kind of heating is thermal. See, calcium carbonate. CaCO3 is calcium carbonate. When you heat, calcium carbonate is nothing but limestone. When you heat the limestone, what happens is CaO separates with Ca and one oxygen separates, and the carbon dioxide separates. What is happening? Limestone is giving rise to quicklime. CaO is quicklime. This formula is important here. CO3 is limestone. CaO is quicklime. And CO2 is separating. That means decomposition is taking place. That is due to heating. Direct sunlight can do minimal impact here. Heating does maximal impact here. So this is thermal decomposition. Limestone, quicklime and carbon dioxide. This is example for thermal decomposition. Easy. Next is electrolytic decomposition. Electricity, electro. This is now the decomposition can be due to electricity. See example. Water can be broken down into hydrogen and oxygen. Due to electricity, it can be broken down into hydrogen and oxygen. This process is called as electrolysis. And electrolytic decomposition is the type of chemical reaction taking place here. See here, water molecules can be separated like this. When the water is connected to a current, to a charge, all the hydrogen molecules will come this side, all the oxygen molecule will come this side. Separation of hydrogen and oxygen. This is electrolytic decomposition. This is also easy. Is there any difficulty in this? If there is any kind of difficulty, kindly comment it down, or you can directly message us in WhatsApp, Telegram, or through any kind of media. You can directly call us also. We'll be always there to clarify your doubts. Okay, anytime we'll be there to clarify your doubts. All that we want is for you to clear this examination. Okay, next, oxidation and reduction reaction. Next is oxidation and reduction reaction. What is oxidation? What is reduction? What is oxidation? What is reduction? So let us first understand what is oxidation, what is reduction. Two kinds are there. One is oxidation. Oxidation. The other one is reduction. Two kinds of reactions. Two kinds of reactions. Now the additions. I'll tell you what an addition. What is addition? I'll tell you. Addition. Removal. I'll tell you what is removed. Addition and removal. Both of them adds and removes an element. Adds and removes a compounds. So what are them? See, by the name, oxidation means you are giving oxygen. So what is added? Oxygen. If an oxygen is added into the chemical reaction, if the compound gets that oxygen, that is called as oxidation reaction. That is what we add is oxygen. So what we are removing, the opposite, always the other end of oxygen is hydrogen. What we are removing is the hydrogen atoms. Similarly, the opposite is reduction. What we add is hydrogen. What we remove is oxygen. Simple, easy concept. This is about oxidation and reaction. Oxidation and reduction reactions. Very easy concept, sir. Don't ever forget, my friends. This is a very easy concept. Don't ever forget. Please understand, you will not forget. You do the ratta morning, 100% you will forget. Don't do that. Fine, don't do that. Now, the other name. What is the other name, sir? The compounds which perform oxidation reaction. The compound which performs the oxidation reactions are called as oxidizers. The compounds or chemicals which perform the oxidation reactions are called as oxidizers. The ones which perform reduction reaction are called as reductants. Reducers. Reductants or reducers. Reductants. Reductants. Okay. Easy with this. These 4 names are important, interconnected. Oxidation, oxidizers. Reduction, reductants. Easy with this, right? So, when a chemical reaction performs both oxidation and reduction, in certain chemical reaction, oxidation may occur. That is called as oxidation reaction. In certain chemical reactions, reduction might occur. That is called as reduction reaction. In some other reactions, both of them might occur together. That is called as redox reaction. Redox means reduction, oxidation. Redox, R-E-D-O-X, redox reactions. We'll understand this with an examples now. With the examples now. See now, oxidation and redox reactions. What is oxidation? We know oxidation refers to, you already told sir, that is addition of oxygen, removal of hydrogen. Easy. Reduction means addition of hydrogen, removal of oxygen. See the examples now. See the examples now. There will be one single example. 2Cu plus O2. 2Cu plus O2. You are adding oxygen to copper. When you are adding oxygen to copper, oxygen shall be taken by copper. It will become copper oxide. Copper oxide. That is, oxygen is being added. So it is called as oxidation reaction. Oxidation reaction. Copper gets oxidized. Now, copper oxides are there. You have to reduce it. What you do for the copper oxides to reduce is you add hydrogen. Then that oxygen will go towards hydrogen. That will become water on one end and it will remove oxygen. It is removing oxygen. Balancing, satisfying either one of them is enough. Now it is not adding hydrogen. It is not adding hydrogen to copper oxide. It is removing oxygen. Satisfying any one of them is enough. Satisfying any one of them is enough. No, it is not adding oxygen to this, but removing the hydrogen, removing the oxygen. So it is removing the oxygen and making copper alone. So this is the example for reduction reaction. Now we'll understand what is reducing agent, what is redox reaction. Oxidizing agent, that is oxidizers. Reducing agent, that is reductants. Oxidizing agents are substance which supplies oxygen, removes hydrogen. Same thing. Now, in this sequence of CuOH, which is the oxidizer, which is the oxidizing agent. To satisfy oxidizing agent, it should be either adding oxygen or removing hydrogen. So, if you see the CuO, the copper oxide in the following reaction, what it is doing to the hydrogen? What is it doing to the hydrogen? It is adding an oxygen. It is adding an oxygen element to the hydrogen. So it supplies oxygen. It is satisfying this, right? It is satisfying this. So it is called as oxidizing agent. Similarly, in the same equation, CuO plus H2. In CuO plus H2, what is H2 doing here? H2 is taking away the oxygen and keeping to itself. It is removing the oxygen. It is satisfying this condition. So hydrogen is an example in this equation for reducing agent. Same equation, copper oxide acts as oxidizing agent. Hydrogen acts as reducing agent. The same equation can be given. It can be asked which is oxidizing agent, which is reducing agent. Simple one but confusing one. Okay, get a hold of this. Second one, redox reaction, meaning both reduction and oxidation is taking place. Same equation again. This is performing oxidation, this is performing reduction. So both is performing in the same reaction. This is an example for redox reaction. Easy. Next is effects of oxidation. What are the effects of oxidation? When the oxidation occurs, corrosion might occur. See, iron will be there. For iron, when the iron reacts with oxygen, and the rainwater, that is H2O, a compound will be formed, that is hydrated iron oxide, hydrated iron oxide. Hydrated means water. Iron oxide, hydrated iron oxide. This will be in brown rust. This is corrosion. Remember this formula. 2Fe2O3 XH2O. This is the formula for rust. Okay. And rancidity, oxygenation or the effects of oxidation might also cause rancidity. What is rancidity? Rancidity is oxidation of fats and oils causing unpleasant smell. You can have you ever observed oils or fats kept in the environment or outside for a longer period will give you that very bad unpleasant smell. Okay. Why? What happens here is oxidation occurs with the fats or oils. That will go a chemical reaction that will provide a new gas that will be unpleasant in smell. That process is called as rancidity. Example, spoilage of chips, butter and fried. When it is spoiled, we'll get that smell, right? Will it be good to smell? No, that will be bad. That process is called as rancidity. Fine with that? Easy. How do you prevent rancidity now? When you add more antioxidants, that is, it will reduce the process of oxidation. When you add antioxidants, it will reduce the rancidity. That is one thing. Packing foods in nitrogen gas. We would have observed Lay's packet. It is blown this big, and we criticize always Lays are only 4 or 5 in number. It is filled with nitrogen gas. Yes, that is a marketing strategy. It is filled with a greater amount of nitrogen gas. The gas which is inside the Lay's packet is the nitrogen gas. One of the main purposes to remedy this rancidity, but they are also using as a marketing strategy because they're inflating the size of the packet. So the gas is nitrogen there to prevent rancidity, the spoilage of chips. Storing food in airtight containers. So what happens? The air doesn't come inside. When the air doesn't come inside, oxygen doesn't enter. Oxygen doesn't enter means oxidation can be limited. Fine, easy. Refrigeration. Similarly, refrigeration. Next is keeping food away from light. So all this will reduce rancidity. So the last slide will be the key terms or the revision of what we discussed, which you already know. What are reactants? The left hand side ones. What are products? The right hand side ones. Okay. What is a combination reaction? AB plus BC giving rise to ABCD is a combination reaction. What is decomposition? AB giving rise to A plus B. The breaking is called as decomposition reaction. What is displacement reaction? The more reactive element displacing the lesser reactive element is called as displacement reaction. What is double displacement? When the displacement occurs in both the compounds, that is called as double displacement. Oxidation means add oxygen or remove hydrogen. Reverse in reduction. Redox reaction means both occurs in a single equation, that is redox reaction. What is corrosion? Hydrated iron oxides is called as corrosion. The formula for rust is 2 the whole Fe2O3 XH2O. Fine. Remember that chemical compound. What is rancidity? We discussed it just now. Okay. This is all about the chemical reactions and equations. Easy chapter, right? It is a very easy chapter. Just that we'll get confused in a few places. But with frequent revision, this is most easy chapter. Never come with a preoccupied mind that chemistry is difficult. Chemistry cannot be studied. So many equations, so many numbers. No. Chemistry is easy. You understood this chapter, right? Thank you so much. Study very hard. Make your parents proud. Make them proud. Make your society feel prouder about you. Okay? All the best for your examination. This is Reddy Prakash with you. We will always be in constant touch with you. Thank you so much.